Hey everyone, welcome to Code Harmony. Today we are going to have a look on the LeetCode problem number 2516. Take k of each characters from left and right. This is another good sliding window problem and you will definitely learn something new out of it. Let's have a look on the problem statement. Here what is given to us? We will be given a string and that string is going to have only three type of characters, either A or B or C. And along with that string, we are also given a non-negative integer k. And what operation we have to do on it? They are saying that each minute you may either take the leftmost character of S or the rightmost character of S. Okay, this is allowed to us. And what we have to return is minimum number of minutes needed for you to take at least k of each character. If it is not possible, return -1. Okay, they are saying that we have to do some kind of operations on this string. We have this left pointer, right pointer, and here either we can take out the character from the leftmost edge or we can take out the character from the rightmost side. And we have to keep on doing this operation, and every operation is going to take 1 minute. So after certain amount of operation, we should have at least k quantity of each character. So count of A should be greater than equal to k, and count of B should be greater than equal to k, count of C should be greater than equal to k. And as per the statement, k value is 2. So A should be greater than more than 2 times, B should be more than 2 times, C should be more than 2 times. Okay. And we have to minimize that time, because we have multiple possibilities. If we keep on taking element from the leftmost side only, and we keep on taking element from the rightmost side only, so we have multiple possibility. So whenever we have picked as many characters where the count of A, B and C is surpassing k, then we have achieved our result and we can capture the minimum amount of time. Okay, this was the problem statement, and first thing that came to my mind is that in every step we have two possibilities, that either take element from the left or we can take element from the right. If I am taking element from the left, and I will see the count, and count of our desired result is that we require A, B, C, k number of times, more than equal to k number of times. So if L is A, I will just decrement my desired value of A, and then I can move further with the same problem statement. So the subproblem is of the same nature. Whenever the subproblem is of the same nature, we think in terms of recursion. But here, if we have a look on the constraints, the s dot length is going from 1 to 10 power 5. So the given input string can be of very large size. And along with that, what is the time complexity? In every step, we are making two decisions, and two decisions means two subcalls. So every time we are making two calls, so the time complexity will go in 2 to the power n. It will be exponential time complexity. So that is going to make TLE for bigger string values. For small test cases it might pass, but for the bigger or lengthy S values, it might give you TLE. So we are not going to go with the recursion here in this. So if not recursion, what we'll choose? We'll choose sliding window here. As per the problem statement, we can either choose element from the left or either choose element from the right. So let's say I have chosen A from the left. And now I have A 1 number of time, B 0, C 0. Then if I choose A again from the left, then A will become 2. And I choose B will become 1. And I keep on choosing till this moment. I will get all the values greater than equal to 2. Because at the last index, the C value is getting equal to 2. And all the values should be greater than equal to 2. So I will achieve the result at the last index. So how many minutes we consume? What is the length of this string? The string length is 12. So we took 12 minutes in this case. if let's say I am taking 4 elements from the starting. 4 elements from the starting means A value is 3, B value is 1, and take the remaining elements from the ending. C I took from the ending, then B I took from ending. So C is becoming 1, B is becoming 2, and then 2 times A, which is 5, and then again C. Now we have all the elements here in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here in this situation, I took 9 minutes. Let's take one more example. If let's say we keep on taking element from the right, then I think at this moment I will be getting my answer. This moment means 12 minus 2, which is 10 minutes. So 10 minutes will be taken. These are the candidates to our answer, and we have to get the minimum number of minutes for any possibility. And here what can be that possibility? So let's say if I take 2A from the starting and rest of the element from the ending. Now we will be having A 4 times, B 2 times. We are taking AAB from the starting and CAABC from the ending. So B is coming 2 times, this, and C is also coming 2 times, and then A is coming 4 times. In total, we are taking 8 minutes. And this is the minimum. You may check that there is no other possibility where we can get less than 8 minutes to achieve our result. So here what we did is we took some portion of the string from the starting, some portion of the string from the ending. Here I picked AAB from the starting, CAABC from the ending. So we are sure that our result, we are going to pick element from the extreme end. So we will definitely have some portion from the starting, some portion from the ending. And what is the middle portion? Just think of that. A. Middle portion is the portion when if we remove the middle portion, then we will still be able to manage at least k quantity of A, B and C. And that middle portion should be the maximum portion. This is the maximum possible option in the middle section, because we are minimizing left side and minimizing, let's say the left side is of size A, the capital A, and let's say right side is capital B. So the A plus B our resulted minutes, and those minutes we are minimizing. If we are minimizing those minutes, it means that the remaining portion will definitely be a substring, right? Because it is in the middle, and it is definitely a substring, and that substring size should be maximized, because A plus B is the minimized, the substring size would be maximized. So instead of doing the sliding window, or instead of try to figuring out the starting end or ending end, we just try to figure out the middle portion. So what we will do is we will try to find the substring, and we will try to maximize that substring. So after removing that substring, we will still be able to manage A, B, C in minimum at least k quantity from the small chunks from starting and ending. Okay. So my problem statement is converted from this one, the given in the problem statement, to this one. So we'll try to figure out this. And what is this? This is a sliding window, and a window size can be, you can say, we are starting from left equal to 0, right equal to 0. And whenever we are adding element in it, we will just try to maintain some kind of counter, that after considering this substring, how many quantities of A, B, C will be in the remaining portion. First of all, when we are going to start, this sliding window is going to be of 0 size, It means that in the remaining portion, what is the quantity? That quantity I can store. Quantity of A, quantity of B, quantity of C. This should be the actual quantity I got in the string. In this string, I got 1, 2, 3, 4, 5, 6, 7, 8. 8A and 2B and 2C. So this is the actual count array. And whenever we are incrementing our sliding window in the middle, we'll just keep on decrementing the counter from it when we are ignoring the element. Whenever we are trying to increment our substring, we will keep on adding element and keep on tracking the count of the remaining of the elements in the remaining portion. And if that count is still valid, we will keep on expanding our current window. And when my window is getting invalid, it means that the count of the remaining elements in this remaining portion is going less than k. Let's try to make a dry run over this example, then it will be more clear to you. Now this is my given problem statement, and here this is the string, and now actual counter of A, B and C is 8, 2, 2. Now I will try to make my sliding window left and right, or you can say beginning or ending, and I will be iterating using my ending pointer, or let me call it L and beginning and ending. I will be taking my beginning pointer and ending pointer, and ending pointer will go from 0 to n minus 1. Okay, and as the ending pointer is going from 0 to n minus 1, we'll keep tracking of the window size. So currently this is the character, so I will decrement value of A. I decremented value of A, so it has become 7, 2, 2. And my current window is A. This is still valid. Now it is the time to increment the window. So I will try to further increment the window, and the window will be AA, which is 6, 2, 2. It is still valid. When I increment the window to B, it will be 6, 1 and 2. 6, 1, 2 is not valid. It means I have to remove elements from this window. I will remove A and it will become 7. I will remove A, it will become 8. When I will remove B, it will become 2. So 8, 2, 2. No element in the window. And now I am at beginning at this and ending is also at this. Now I will try to add the window again. A is in the window and the size is 7, 2, 2. When I will keep on adding A when I am at this moment, so A is coming 4 times, so A will be decremented by 4. So 3 times A, and these are the 2 elements. Now when I try to add C, so C counter will become 1, and this is not valid. So we have to decrement the window, and in this way I will just do the iteration using the end pointer. And what is we are capturing in this sliding window operation? We will capture the maximum possible window length which will be formed during this process, and the maximum will be formed something like this: A, where the remaining string is going to have these many counters. A is 8 in total, so remaining string is going to have 4 element. So if I choose this substring, the remaining portion on the left side and the right side in total is going to have these many characters, and this is still valid. And if it is valid, this is going to be my window that I'm going to remove. I will just capture the maximum size of that window we have to subtract. And let's say the size of this is C. And now I want to calculate A plus B. A is the minutes from the left, B is the minutes from the left. So A plus B plus C is the length of the string. The length of the string we know, and C we have calculated. So the length of the string minus the substring, we will be having sum of initial and ending substring. And the sum of this initial and ending substring is our answer. That is minutes we are going to take to be able to have at least k elements k items of ABC. Okay, let's try to write the code for this approach, then you will be having more understanding of it. And we are doing one iteration using ending pointer over it. So this is going to take order of n time. These string are of 3 size, so maintaining pointer, checking counter, checking the count of these values are not going to add any time. So it's an order of n solution. Now let's try to write the code. First of all, I need to have the count of A, B, C in my initial string. So for that I'm taking a count array is equal to new int of size 3. Let's say n is the s dot length. N is the length, and firstly I will just consider a negative case where the string is not having enough quantity of k. First of all, let's see whether this count is not valid. It means any of the count of A, B and C is not as equal to or greater than equal to k. In that case, we'll just return -1, and whether the count is not valid. I'm just taking a helper function. So private boolean valid integer array count. I need to compare it with k. Instead of passing, I'm just taking a global variable. This dot k is equal to k, and here I need to iterate every value for int I in count. If any value is less than k, just return false, otherwise return true. Okay, this is my valid function, and if it is not valid, I am directly returning -1. Now I will try to get the middle string that we can remove using sliding window approach. For that, what is the begin and ending? Begin and ending, let's keep it 0, and my sliding window pointer is end, while end is less than n. First of all, in the sliding window questions, the approach is something like whenever we are processing the sliding window from the previous iteration, we are definitely getting a valid sliding window. And in this case, from the previous iteration, there is no previous iteration. It means from previous iteration, we are getting empty sliding window. And in this sliding window, I will just add current element. So current character, I need to see char ch s dot character at end. And this character end, if I want to remove it, it means I need to remove this value from this count as well. And this count is the actual count of A, B, C in the remaining string. If I'm considering any character, I'm considering it in my substring, I will have to remove it from the remaining string counters. So that count minus of this character minus A. Okay, this I have removed, and now I need to remove all the elements who are making my sliding window invalid. So while the counter is not valid, this count should be valid. How it is valid? Because count is the count of ABC in the remaining string, and it is valid if this function is giving true. Okay, that is fine. Along with that, for any window, begin should always be less than equal to end. And if it is not the case, we don't have any sliding window to remove any element. So while this is the case, it means if it is not valid, I will just keep on removing element from the starting begin plus, and before incrementing the begin value, just return that counter to the outside portion. Counter of s dot character at begin minus a plus plus. Okay, so let's say in my sliding window I am taking AAB. When it is becoming AAB, it is getting invalid, and now I need to remove element one by one. When I am removing A, I need to add it in the counter. I am adding it in the counter and then incrementing the pointer. Okay, fine. And now my sliding window is valid. Now it's time to capture the result. And I am also taking a variable max. We can initialize it with -1, and max is going to be the size of the substring we can trim from the s. The max is going to be math.max. What is the max, and what is the length of the substring from beginning to ending? Ending minus begin plus 1. So this is the length. And now after this operation, I have calculated my maximum substring that I need to remove. If I know the maximum substring, what is the value of a plus b, subtracting this maximum value from the string length. So return n minus max. This is going to be my answer. If max is the maximum value, then n minus max is going to be the minimum value. Private bool. Okay, it is a boolean. And there is one more thing. I have not initialized the count array. So the count array is something which should be initialized in the starting for every character. I need to iterate over every character ch s dot char at s dot to character array. Count character, count of a at 0 index, count of b at first index, count of c at second index. So I have the counter, and now this is the string length. If that count itself is not valid, then no need to go further. Then calculate the maximum substring that we can remove. If after removing that substring I know the remaining string, and the remaining string letters will tell me how many minutes I will need to solve. Okay, let me run over sample test cases. Giving me TLE. It is giving me TLE. Why TLE? Just increment the end pointer, because we are using while loop. Sample test cases are passed. Submitting the problem. Submitted successfully. Hope you understood the problem. Thank you guys. Bye bye.